All right, hello. In this video, we are going to learn about something called DeMorgan's Law and know also when it applies, right? It involves conditional or if logic, which is what we're working on in this chapter. And then we'll learn a second property called I don't really know what the name of it is, so I just call it the distributive property. But it'll make sense once we hit it. All right, so this is going to involve like conditionals with like multiple parts, like an A and a B part. So I just want to review real quick, like when you have two different statements and you pair them together, there's four possible scenarios. They both could be true. The first could be true, second false, first false, second true, or they both could be false, right? And then we talked about how we and them together and or them together and then do the not. Pause the video here and see if you can remember what the correct truth value is for these different scenarios. You can either write them down, or if you just want to like think through in your head what goes here, like if A and B are true, what is A and B? If A is true, B and false, what is A and B? So pause the video and fill in the table before watching the solutions. Okay, this and means they both have to be true in order for A and B to be true. So that happens only in the first case. If either one is false, then the whole and statement is false. Or is sort of the reverse of this. Either one of these, either A or B, can be true for this or to be true. So here, at least one of them is true, at least one is true, and then the last case, neither is true, so that is false. The exclamation point just reverses it. So if it was true, it turns false, and if it was false, it turns true. Okay, and I bring these up because some of these questions in the AP test are pretty tough, but if you're really in a jam, you can do these truth tables, and that'll help you. All right, so if you want to get down what DeMorgan's Law is, all right, so it involves when you have the not on the outside of maybe let's raise this up to save some space here, but when you have a not on the outside of an and, you can basically sort of distribute it in, and then you're going to get not A, not B, but you're going to reverse the symbol between them. So basically saying not A and B is equivalent to not A or not B. Similarly, if you have not A or B, if we distribute it in and change the sign in the middle, we have not A and not B. Okay, and so to help make some sense of this, I'm going to take this first statement and just go through the truth tables with you. All right, so we're going to build the truth table and then show that not A and B is the same thing as not A or not B. We're going to build each part of the little statement to build the bigger overall statement. All right, so I'm going to build this statement here and this statement right here and see that they have the same truth values. Okay, and so our starting thing is A and B, and it's going to be just like in that first slide, all the possibilities. You can have both true, you can have A true, B false, B false, sorry, A false, B true, and then you can have both of them be false. Okay, and then I've got to build the little pieces. So for this statement, I need A and B. So I guess I could copy these just from the front, but that's where they both have to be true. And that happens only in the first case. Okay, now we just need to do the not of that. So once I've built A and B, I'm going to take that column and just do the not, reverse it. So I'm going to take this one and just reverse it. So if it was true, it's going to change to false and vice versa. Okay, so now I've built this part. So now I just want to build the other part and verify that they're really the same. So in order to do that, I'm going to need not A. So I'm going to go back to my A column and reverse the values. Right, and then I also need not B. So I'm going to go back and look at my B column and I'm going to reverse those values. So false, true, true. Just the reverse of those. Okay, now that I've built these little two pieces, whoops, sorry, I'm on the wrong one, built these little two pieces here, now I'm going to OR them together. So I'm going to do not A or not B. All right, so here I need either one of these to be true, either not A or not B. So that's not the case here. We do have one true here, we do have one here, and we do have one there. Okay, so the whole point of this is to show that if you look, this column, this not A and B is the same thing as not A or not B, which is what we see over here, right? They have the same truth values. Okay, so that's kind of a lot of work, and I don't necessarily recommend doing that on all the AP questions, but if you really get stuck and have a hard time making sense of it, truth tables can help you get closer to understanding it. You just have to remember these 4 values and then build the statements from there. All right, so here's a couple sample questions involving DeMorgan's Law. These are actual conditionals that I've written before. Well, at least the first one is. I'm not sure about the other ones, but first one is for sure. So see if you can apply DeMorgan's Law to the situation. Pause the video, give it a shot, and then check your answers. All right, so if we want to ship to any state besides the Dakotas, maybe we don't like the Dakotas for some reason, right? So we could do not South Dakota or North Dakota, but what DeMorgan says is an alternate way to do this conditional would be to not both of these. So say not South Dakota and not North Dakota. Okay, that's the same as the original statement, right? So we're just going to distribute the not and then change the symbol in the middle to an and. All right, number 2 is to try to reverse that. So we're essentially going to pull the not to the front. So we have not male or not tall. So we're going to do a not in front of parentheses, and then we're going to have male, and then we're going to change it again to an and. So not male or not tall is the same thing as not male and tall, right? And if you kind of think about that, like think about people that are not male or not tall, that would be the same as people that are not male and tall. All right, last one. It's just with an and, not glasses and not piercings. Again, we're going to pull the not to the front, so it's going to be glasses or piercings, right? So we're going to pull the not out and switch the symbol in between them. All right, the second part of this is sort of another situation involving conditional statements and and ors. This time we actually have 3 different statements, so we have A, B, and C. All right, and I call it the distributive property because basically we see that we have this A or B and C. So the A or part just gets distributed to both so that what is on the left here is equivalent to A or B and A or C. Okay, so this time we keep the and then just do an or A and an or C and them together. Okay, and again, both sides of that are equivalent. You can do the same thing with an and, except now the or is inside of the parentheses. So here we're going to distribute the and to both parts, the A and the B, and then we keep the or in between them. So here's a couple examples. I'd actually have you pause the video here and see if you can figure out what are these equivalent to using our distributive property. All right, so the first one, we're going to distribute the male and. So we're going to have male and glasses or male and tall. Sorry, I cannot make that ampersand symbol, but hopefully you get the idea. All right, next one is just distributing an or. So this one's going to be female or glasses. Keep the and in between them, and then you get female or brown hair. Again, sorry for the not being able to fit it all in there. All right, and then the last one is we're going to reverse. So we have this and this, or smart and soft. So we're going to pull the smart and to the front. So it's going to be smart and then inside parentheses, we're going to have a junior or a sophomore. All right, and this one's a little bit weird because we know that there's no such thing as a smart sophomore, but we'll just have to pretend that you could be smart and a sophomore. All right, but that's just reversing this distributive property. Okay, hopefully those examples help. I'm going to make a second video that has actually some sample AP questions for what this looks like on the AP test, right? So you might have to apply these properties on certain AP type questions. So that'll be in part 2 of today's lesson.